Assalamu alaikum and welcome back. We are today going to solve the numerical. The data of which has been given in our previous lecture. रात किस lecture में कर स्टार्ट numerical assignment में procedure में बोले तो ये कितने करना solve. So that problem was concentration of ZnSO4 data था वो इतनी ZnSO4 zinc sulfate concentration was equal to 0.160 mole. Number 2 is that you were given the value of current was equal to 1.70 amperes. Time was equal to 230 seconds. Because this volume of solution was equal to 300 ml and the efficiency, current efficiency was equal to 90%. सवाल उस प्रश्न अगर इस जिंक सल्फेट सॉल्यूशन 0.160 मोलर having volume equal to 300 ml electrolyze करो current efficiency छात्र equal to 90% and current of 1.70 amperes was passed through it and in साथ electrolysis में deposition of Zn2 positive ions जैसे add cathode पाथकुनिस solution बच्चे that solution as mazim Zn2 positive ions आसन तीनिस concentration का बराबर आसी idea तो मैं रात तो ही and let us see how we will solve this problem. So you can write it solution. Number 1, yam satanis 0.160 molar solution of zinc sulfate ch electrolytic cell mas mawjood before electrolysis and amic volume ch equal to 300 ml. Then molarity his definition chote pai ya molarity his equation ch varia molarity ch asan barabar number of moles of solute it into solute ZnSO4 number of moles of solute divided by volume of solution in liters. Sharp expression. The expression is number of moles of solute divided by volume of solution in ml and then multiplied by 1000. Third expression is molarity that is equal to agar in terms of millimoles. Number of millimoles of solute Zn2 positive ion is considered and divided by volume of solution in ml. This is equation of molarity. So from this we can calculate the number of millimoles of solute that will be equal to volume multiplied by molarity agar we use kare the expression. So we can write down that number of millimoles. In terms of moles, in terms of millimoles. Now because volume has been expressed in terms of ml, it is better that we take the moles in terms of, so we take the concentration of solute or express the concentration of the solute in terms of millimoles. So number of millimoles of Zn2 positive. Income number of millimoles yelis kat karo initial yim saath mein isme electrolysis karmus chikin. So we can write down initial number of millimoles of Zn2 positive ions that will be obviously equal to molarity and this volume of solution in ml multiplied by molarity. So volume of solution in ml is equal to 300 and then molarity is equal to 0.160. Let's multiply this. This is 3 6 18 and then 48 and then we have 1 2 3 decimal 1 2 3. So this is 48 is the number of millimoles. So yeah, before the electrolysis has been carried out, when the solution is ready in the electrolytic cell, then the initial number of millimoles of Zn2 positive ions is equal to 48. This we have calculated by employing the formula that number of millimoles is equal to volume of solution in ml multiplied by molarity. One inside cinemas electrolysis karumuz cha. Electrolysis mas kya gesi Zn2 positive ions will be deposited deposit on cathode. Rather the formula that number of moles agar tay ase ya yem sat te won mass of substance kuta gets deposit pata karte tai prashu karu number of moles. So number of moles of Zn2 positive ions yim atmas deposit asen demus deposited, that will be equal to sukat barabar hai. So as equal to this formula rahtoi, that will be IT divided by that is valency factor multiplied by 96500 multiplied by efficiency. So kuta number of moles gasan deposit out of 0.160 molar solution tamas kusa Zn2 positive ions gasan deposit on cathode by passing current I, where we have the value 1.70 ampere and time is 230 seconds. So suppose me or formula chota in case of agar efficiency mention asked, we have to multiply by that percent efficiency. Agar ne dit as efficiency atmas kin tel she efficiency plus so dit ya efficiency value is equal to 1 ye hanch me rat karus. So let us put the values. I is equal to 1.70 amperes, time is equal to 230 seconds, and valency factor of zinc of reaction was just electrolysis was just reaction gas deposition of Zn2 positive ions that is cathodic reaction, they will accept 2 electrons to get converted into Zn, so valency factor is equal to 2. So that is 2 multiplied by 96500 and then multiplied 90% is the efficiency, 90% matlab 90 divided by 100. So you have to remember this, that initial number of millimoles was 48, and when you solve it, the number of moles of Zn2 positive ions that will be equal to 0.00182, but this is number of moles. Number of moles of Zn2 positive ions that have been deposited on cathode, that comes out to be 0.0. agar simple multiplication division kelu, the value comes out to be 0.00182. magar zaruri ka cheez number of moles, not the number of millimoles. And this number of moles ye baat yeh kar baith ke lekin agar decimal part na ho so this is 1.82. so 1 2 3 3 digit part now on the right hand side, that means that it can be multiplied by 10 to the power minus 3. This is the number of moles of Zn2 positive ions that have been deposited. Class today you can inshallah 48 triatom if mazura chime 48 is the initial number of moles. Yet for after analysis value of x1 equal to the value of x2 kaditay number of moles left will be equal to x1 minus x2. So initial number of millimoles you just calculate correlate sahan throws yan initial number of millimoles is that was equal to 48 deposit to the atmos deposited moles. Now this is millimoles deposited moles of Zn2 positive, that is equal to 1.82 into 10 to the power minus 3. Now let us convert moles into millimoles. Agar ye millimoles हम convert करो इनको देखो 1.82 into 10 to the power minus 3 आज multiply करो so you can raise power 3 से. So then 10 to the power minus 3 and then into 10 to the power plus 3, that is equal to 1, and this comes out to be 1.82. You will convert in terms of millimoles. This number is the number of moles of Zn2 positive ions that have been deposited. The number of moles can be converted into number of millimoles. It can go in. After multiply 10 raised power 3 से क्या 1000 से cross multiply आप millimoles के convert moles के convert into millimoles. So initial number of moles is 48. The initial number of millimoles is 48. The number of millimoles that have been deposited. This is your x1. This is your x2. आपको कुछ in solution as Zn2 positive ions बच्चे. So can I write down that number of millimoles? Number of millimoles of what? Zn2 positive ions. Left in solution. That will be equal to initial number of millimoles minus number of millimoles that have been deposited. So the value is 48 minus 1.82. Okay? So that is equal to 46 point. Is it? 46.18. So this is the number of millimoles of Zn2 positive ions that have been left in the solution. But when you take question 2, so you molarity of Zn2 positive ions, assuming that volume of the solution remains constant. So it is the number of millimoles of Zn2 positive ions that have been left in the solution. Then we have volume of solution using to the questions that is equal to 300 ml. We can easily calculate the molarity. Number of millimoles that have been left in the solution is this. Volume of solution in ml is 300 ml. Then molarity is equal to number of millimoles divided by volume of solution in milliliters or ml. And you can calculate number दोनों के रूप में पावर डिवीजन अगर divide करो एक्ट क्या मिलता है हेल्प में टोटल लेके that ultimately total therefore molarity of Zn2 positive ions left in solution will be equal to shabash, the value is 46.18 divided by this is 300. Now this is number of millimoles and this is volume of solution in ml. And from this comes up to be 0.154 moles per liter. Shabash. अगर तो तारुना screenshot नहीं तो जल्दी. So this is one of the questions, very much important question, where efficiency is mentioned. This is question number 1. Okay, let us move to one more question where efficiency is mentioned. Write down question. Simple question one more time. Efficiency. If I say if I have molten aluminum oxide was electrolyzed by passing current of 96.5 amperes for 1000 seconds. Calculate 1 number of moles of aluminum deposited on cathode 1, 2, mass of aluminum deposited on cathode 3, number of equivalents of aluminum deposited on cathode. Molten aluminum oxide was electrolyzed by passing a current of 96.5 amperes for 1000 seconds. Then you may be asked to calculate the number of moles of aluminum deposited on cathode, or mass of aluminum deposited on cathode, or the number of equivalents of aluminum deposited on cathode. Now the electrolyte is in molten state, then we know that the substances deposited at respect to electrodes actually come from the electrolyte itself. So let us see, बिल्कुल easy question चाहिए. Shabash. If I see the solution, we are given that current is equal to 96.5 amperes and time is equal to 1000 seconds. Okay. Electrolyte is aluminum oxide Al2O3. This will dissociate as Al3 positive plus, and it will give us oxygen, or it will give us 3 times O2 negative. Now cathodic reaction cathode reaction important. Aluminum 3 positive will accept 3 electrons and it will be converted to aluminum solid. Balanced chemical reaction must valency factor का दृष्टि वारिया तरी. Balanced chemical reaction मज़ अगर तय 1 हो, for example aluminum 3 positive was क्या चु valency factor का आसान बराबर आपको cathodic reaction was number of electrons gained directly, but that is for 1 atom or 1 moles में 1 atom or 1 molecule. क्या इस्तेमाल साथ में यार lost or gain का मुझे कहते हैं. So valency factor का निश्चित तरीके से याद बाइकिंग प्रॉब्लम नहीं. अगर balanced reaction के हम बात करें question तो aluminum स्कूटा ऐसे valency factor that is actually equal to the number of electrons gained or lost involved in the reaction, that is 3 divided by stoichiometric coefficient. Stoichiometric coefficient is equal to this 1, so that comes up to equal to 1. So valency factor is equal to 3. A reaction with this valency factor, that valency factor is equal to 3. Wow. यम साथ electrolysis गसान च question च पछान तो एक दूसरा calculate number of moles या number of millimoles, number of equivalents या mass of the substance which aluminum chemistry that has been deposited on cathode. Last में formula था with that is number of moles. Now this is number of moles of aluminum deposited that will be equal to, that's a formula uses IT divided by 96500 multiplied by valency factor. Now यह question इसमें शुरू था efficiency is काफी तीन. अगर मैं efficiency multiply की था या मतलब वो पाने efficiency is equal to 100%, that is equal to 100 by 100. So if it is not mentioned, then by directly problem we can write down that the number of moles of aluminum deposit can be given by the expression IT by 96500 coulombs and then multiplied by valency factor. Valency factor that is equal to 3. Now let us substitute the values we have. Current is equal to 96.5 amperes, time is equal to 1000 seconds, and then we have 96500 and then multiplied by 3, and then if you solve it, this is equal to 96500 divided by 96500. This will come out to be 1 by 3, but this is number of moles. So number of moles of aluminum that having deposited on cathode comes out to be 1 by 3. 1, 2. Agar number of equivalents as called that number of equivalents direct formula karbe number of equivalents asan barabar shabash number of moles multiplied by valency factor. Number of moles is equal to 1 by 3, valency factor is 3, so that is equal to 1. So 1 by 3 mole is equal to 1. Sorry, this number of equivalents is equal to number of moles into valency factor. When we put the values, then the number of equivalents of aluminum, precise question that have been deposited, that is equal to 1 by 3, then multiplied by 3, that is equal to 1. Three choices of question is what is the mass of the aluminum that has been deposited. So if number of moles number of moles are equal to 1 by 3, then we have the formula that number of moles mass of the substance divided by the molar mass. And for aluminum, molar mass is equal to 27. So it gives me that the mass of substance that has been deposited is equal to number of moles multiplied by molar mass. Number of moles is 1 by 3. Molar mass of aluminum is, it is gram atomic mass, that is equal to 27 grams. So multiplied by 27, this comes out to be 9 grams. So 9 grams. त्रिशवनी चीज अंदर जवाब. You can note it down. Last problem for the last problem. Shabaz jaldi pahno. Third question is same type. Isto mujhe reference practice this textbook practice question ke. But type is procedure that is time consuming. Iska pan procedure is huge and there which put the time by this question sheet question. That what is the quantity of charge required to reduce 12.3 grams of nitrobenzene to aniline. Nitrobenzene to aniline if the efficiency of current efficiency is 50%. What is the quantity of charge required to reduce 12.3 grams of nitrobenzene to aniline if the efficiency of current is 50%? Number 2, charge it mentioned in the question is number 2, if voltage drop is 3 volts. What is the energy required for the reduction of nitrobenzene? So this is very important question. Quantitative aspect of electrolysis is our score. अगर इस रिएक्शन लेको तमी हिसाब है को तुम सारे प्रॉब्लम में उन्हें ताई वंदम सारे प्रॉब्लम है को के सॉल्व कर बट बिकॉज़ we have to appear in कॉम्पिटिटिव एग्जाम टाइम कम इसलिए गए सु मेथड आसन पाई डायरेक्टली अगर तो अदरवाइज वन न्यूमेरिकल हाई अगर बेहमो क्वांटिटेटिव एस्पेक्ट कर दैट 2 moles require this 2 Faradays 3 Faradays and then therefore this and this and this that will be time consuming. So let us see how we will solve this problem. Data that we have 12.3 grams of nitrobenzene. Now what is nitrobenzene? Nitrobenzene is this C6H5NO2. NO2. This is nitrobenzene. Yeah, nitrobenzene is C6H5NO2 bonded to NO2. This is nitrobenzene. Question 1 which reduce current to aniline. NO2 current NO2 will be replaced by there we have NS2. So this is aniline, NS2, and then this is nitrobenzene and reduction. Oxygen chambers never come. Shabash, tamla introduce hydrogen. How is this possible? How is this possible? This is possible only then when we remove these oxygen atoms. It can, in presence of H positive ions will combine with oxygen atoms in presence of electrons. Then they converted into S2O. There are 2 oxygen atoms, so we'll get 2 water molecules, and then 4 hydrogen. 4 plus 2 is 6 hydrogen. Therefore, we require 6H positive in presence of 6 electrons. This is it. Gives us this. So this is the reaction C6H5. This is nitrobenzene in presence of H positive ions will accept electrons. We get converted into this is aniline with the production of water molecules. Now see, Ambrochi problem was one meta yamsat a balanced chemical equation asan. Balanced chemical equation was just sahal valency factor problem. So valence factor agar batai vano ya valency factor for this nitrobenzene. This is balanced reaction. Dhyan throw ये valency factor आसी बराबर न्यूनतम formula number of electrons involved in the reaction divided by stoichiometric coefficient. Number of electrons involved is equal to 6. Stoichiometric coefficient of this nitrobenzene is equal to 1. 6 by 1. This is equal to 6. Valency factor of these H positive ions will be equal to 6 by 6, that's equal to 1. Valency factor of aniline will be equal to 6 by 1, that's equal to 6. And valency factor of these twice as 2, what is valency factor that is equal to 6 divided by 2, that's equal to 3. Valency chemical equation was to valency factor या n factor active branches to y as So valency factor is the value equal to 6. 1. Number 2. थोड़ा ध्यान रखना कि अगर इक्विवेलेंट मास आशी करें या इक्विवेलेंट वेट इस करो कैलकुलेट बात करो इक्विवेलेंट वेट कैलकुलेट इक्विवेलेंट वेट ऑफ that is nitrobenzene this is nitrobenzene or C6H5NO2. This will be equal to its molar mass. This will be equal to its molar mass divided by valency factor, and its molar mass is equal to 123 grams divided by whole valency factor, that is equal to 6. Idhar hoga equivalent weight of nitrobenzene. This is valency factor is value equal to 6. Equivalent weight draw equal to nitrobenzene, that's equal to 123 divided by 6. Obviously in terms of grams, so this is 123 divided by 6 grams, that is, and then let us see. What's the formula? Formula sheet contains that mass of the substance is equal to equivalent weight multiplied by charge Q divided by 96500. You will be theoretical mass in certain characters multiplied by meter. multiplied by eta. Once you solve problem. You see the mass of the substance is equal to, the question is asking about 12.3, that is the weight of nitrobenzene, 12.3 grams. In the value I can, neta 50%, 50% is 50 by 2, that is, sorry, 50 by 100, that is equal to 2. This is a value. Value there, this is 12.3 is equal to equivalent weight बराबर 123 by 6 शाबाश into Q. चेस calculate करूँ divided by 96500 into neta 50%, that is equal to 50 divided by 100. You can calculate the value of Q. I think that's a substitute one value. Q was needed a value equal to perhaps 115800 coulombs. Coulombs. Wow. The is also Japanese question percent. If you solve, this is simple mathematics now, you can calculate the value of Q. But our problem was they mentioned efficiency, efficiency 50%. The is what is the energy? Electrochemical cell must be electrical energy whether it is consumed or produced. You will employ the formula that the W is equal to electrical, that is Q into V, whether that is electrical work done or electrical energy produced or consumed. Then we had W is equal to Q into Q value is taken, say for example 115800. I'm not sure, take a point to check, multiplied by voltage the value 3. Now this is in terms of coulombs and this is in terms of Q need to take in terms of coulombs. We showed one of the Spartacus questions that 3 volts, the coulomb voltage. This is either solve kariyo. This is 115800 into 3 solve kariyo in 3 coulomb voltage is equal to joules. This is the amount of energy required to reduce the 12.3 grams of nitrobenzene to LE. I hope you have understood it. यहाँ जी मैं mention करूँ already इसकी कंट्रीब्यूट done करना potential स्टार्ट करने so यहाँ तो ये तो ही pattern तो अगर मुझे क्या doubt आसी so that was clear, they get a message and this is all for today. Thank you very much.